The pool Butler is still in dry dock right now. It's being built on a plastic platform that hopefully can be transferred over into a boat shell, hopefully a barge type structure whenever it's ready to sail. We do have the blade on here. That's controlled by the propulsion system. That's not on here. We've tested it before, and it's in a sealed container, the same as the steering system. They'll go side by side. There'll be some interconnections. It is still a bit of a mess of wires. All the connectors are not installed yet, but this is here for the test. This is a quick demonstration of the pool Butler steering system. It's more or less an airboat, and the radio control is going to move the rudder back and forth. The way it's going to work is by turning the wheel on the radio controller this way or this way, the rudder will go that direction. If you let go of the wheel, the rudder will return to the center position. Rather than a battery, I'm going to power feed the steering system with a power supply, the same voltage as a battery. So it's going to boot up. We'll see some lights on the inside, which is cool. This section back here, there's a Hall effect sensor, and there is a small magnet on the bottom of the rudder. That is the home position of the rudder. Before the propulsion system is allowed to go ahead and run, the rudder has to be calibrated into the home position. Now what's kind of neat is there are some capacitive touch switches that are under the plastic, and they're labeled rudder clockwise and rudder counterclockwise. And we can see if I hit the buttons that it is moving the clockwise, and if I hit the other button, it moves the other and as soon as it hit the Hall effect sensor, the light lit that said rudder home. So it's not calibrated. For this demo, I removed power for a second and moved the rudder by hand. You can't move it whenever it's powered up because the stepper motor's got holding torque on it. But turned power off and moved the rudder by hand to the other side so we could do a demo. And repowered. You see the home calibrate LED is not lit, and we can push these buttons. We can see that it's moving counterclockwise, and then here's the other button for clockwise. As I hit those buttons, the rudder's moving manually, and it stops right on that position, and the rudder home light lights, and that is a run permissive for the propeller to run. It also is a run permissive for the RC control on that rudder to also operate. One of the interesting things in the software, you see we're still in the calibrated position, that not only does the rudder not move when I turn the wheel on the RC, it can't move. The software can detect whenever the transmitter's turned off. It gives a 0 for the pulse width. So whenever it detects that, it does not run code. So we'll turn on the transmitter, and we should be able to operate. And it's beeping because it's got low batteries. So here we go. Maybe if I can get there, I can turn the wheel there, and when I let go, it returns. I'd like the rudder to be faster, but that's the fastest I can make it run with the code and the slew rate for the stepper motor. So you can see that for steering down the road. And the other thing is, with the Hall effect sensor, it doesn't always hit home exactly the same place every time. I'd still need to work on the magnetic for that, but it's not really a big deal. That magnet is used for two things. It's first to set the calibrate. The other thing is it traverses back and forth, and there's a stepper count. So it can only go a maximum to that angle. It's 45 degrees. When I let it go, it counts back to home. And if it doesn't quite make it there, if there's a magnet, right now I think it detected there's a 0, but all I have to do is make it that way, and whenever it does see the magnet, it'll reset the count. So it's not perfectly lining up to 0, but I can use the remote controller here to 0 it out anyway when it's in operation. So you can't see that. That beep is annoying. It's very repeatable, and I don't think that rudder is moving quite fast enough for my liking. But it may be okay for the pull Butler. A little bit more about the control itself. I do have a couple D1000 connectors on here to try and clean up the wiring. This is kind of the operator station wiring goes to the Arduino. This is an Arduino underneath, and on top of that is a DFRobot. This is the L298P. So we're using the analog version. So the other signals we have coming in here, we have 11 volts coming in from the battery. There's a blocking diode here, and that feeds the power to the Arduino. The other supply goes to this 5-volt power supply, and that's wired to the H bridge, and that's what powers the stepper motors. So they have a separate 2-amp power supply. It just bogs down the Arduino supply and gets way too noisy. This other terminal board here is the Arduino 5 volts, and that's used to land all the sensor wiring. So that is the system as it stands today. Looking to get some more connectors added in, and then we will be putting together the entire system and run it all together.